Hello students, in previous class we have discussed how to represent a rational number on a real number line. In this lecture we have to discuss what is the lowest form of a rational number, how to calculate the absolute value of a rational number, and how to compare a rational number. First topic is lowest value of a rational number. What is lowest value of rational number? When a rational number is said to be in a lowest form, a rational number is said to be in a lowest form when the HCF of its numerator and denominator is 1. When the two terms, numerator and denominator, are irreducible. So, when we need to find the lowest term, we need to follow some steps. Step number one is to calculate the HCF of numerator and denominator. To calculate the HCF of numerator and denominator. If the HCF of numerator and denominator is already 1, then the given rational number is already in its lowest form. You don't need to convert it. It is already given in its lowest form. Otherwise, in step number 1, we'll calculate the HCF of numerator and denominator. Then step 2, divide the numerator and denominator by the HCF. For example, suppose a given number is 16 upon 24. 16 upon 24 is the given rational number. We need to convert this given rational number into its lowest form. So first we need to calculate the HCF of 16 and 24. Let's factorize 16. 16 can be written as 2 multiplied by 2 multiplied by 2 multiplied by 2, 2 raised to the power 4. 24. 24 can be factorized as, the prime factor of 24 is 2 multiplied by 2, 2 2s are 4, 2s are 8, 3s are 24. Therefore, the highest common factor HCF of 16 and 24 is given by 2 multiplied by 2 multiplied by 2, that is 8. Since the HCF of 16 and 24 is 8, we have done the first step. Step number 2, divide the numerator and denominator by its HCF. 16 divided by 8, 24 divided by 8. When 16 is divided by 8, answer is 2. When 24 is divided by 8, answer is 3. Therefore, the lowest form of 16 upon 24 is given as 2 by 3. 16 upon 24 can be written as 2 by 3. Here we can see that 2 and 3 both are prime numbers. Their HCF is 1. Therefore, 2 by 3 is the lowest form of 16 by 24. Let's take one more example. Next example is 15 upon 31. Given rational number is 15 upon 31. We need to convert this given rational number into its lowest form. Step number 1, calculate the HCF. HCF of prime factorization of 15 is 3 multiplied by 5, and prime factorization of 31 is 1 multiplied by 31. Since 31 is itself a prime number, so its prime factors are only 1 and 31. Therefore, there is no common factor of 15 and 31. Therefore, their HCF of 15 and 31 is 1. Step number 2, divide the numerator and denominator by the HCF. Since the HCF is 1, so we will get the same number. Therefore, we can say that 15 upon 31 is already in its lowest form. Next topic is absolute value of rational number. Absolute value of a rational number. Absolute value of a rational number. What is absolute value? Absolute value of any rational number is a value without its sign, only numerical value. Whether the given rational number is positive or negative, just remove the sign, take the numerical value only. Absolute value. Absolute value of a rational number is a value without sign, is a numerical value. Numerical value. Value without sign. For example, absolute value of -2. The sign represents the absolute value. Absolute value of -2 is, just put the numerical value. Ignore the sign. Here sign is negative. The absolute value of -2 is only 2. Absolute value of -3/7 is 3/7 only. Absolute value of 1 is 1. Absolute value of -10/3 is 10/3. Absolute value of -1/7 is 1/7. Absolute value of 5/6 is 5/6. Therefore, in short, whenever we have asked for absolute value, just ignore the sign, just put the numerical value, whatever it is given. Let's take some more examples on absolute value. Question number 1. Question number 1. Solve -15, absolute value of -15 minus absolute value of -12. Absolute value of -15 is given as 15 only. The sign between the two numbers is minus. Again, absolute value of -12 is 12. 15 minus 12 is 3. Final answer is 3. Question number 2. Find the value of solve -3/7 plus -5/3. Absolute value of -3/7 is 3/7. Absolute value of -5/3 is 5/3. Let's take the LCM of these two denominators, 7 and 3. LCM is 21. 7 3s are 21, therefore 3 3s are 9. 3 7s are 21, 7 times 7 5s are 35. 9 plus 35 is 44 upon 21. Final answer is 44 upon 21. Next question is to verify you need to verify the result that absolute value of x plus y is less than or equals to absolute value of x plus absolute value of y when values of x and y are given. Value of x is -5/12 and value of y is -7/18. We need to verify this result that absolute value of x plus y is less than or equal to absolute value of x plus absolute value of y. Since we have to verify this, let's take one by one side, then another side. Let's take LHS first, left hand side first. LHS is absolute value of x plus y, where x is minus 5 by 12 and y is minus 7 by 18. Put the values. X is minus 5 by 12, y is minus 7 by 18. LCM of these two numbers is 12 and 18, 36, 12. 36 comes 3 times, therefore 5 multiplied by 3 is 15. In 18, 36 comes 2 times, therefore 7 multiplied by 2 is 14. Minus 15 minus 14 is equals to minus 29 upon 36. The absolute value of minus 29 upon 36 is given as 29 upon 36, which is our LHS, the value of left hand side. Now take right hand side, RHS, absolute value of x plus absolute value of y. Put the values. X is minus 5 by 12, y is minus 7 by 18. Absolute value of minus 5 by 12 is 5 upon 12. Absolute value of minus 7 by 18 is 7 by 18. Again, LCM of 12 and 18 is 36. 3 times 5 3s are 15. 2 times 7 2s are 14. Again, final answer is 29 upon 36. Since LHS and RHS on solving gives the same value, therefore LHS is equals to RHS, hence plus y is less than equals to absolute value of x plus absolute value of y. Verified. Since both the sides are same, the results are same, therefore the result is verified. Let's take one more example. Verify that absolute value of x multiplied by y is equals to absolute value of x multiplied by absolute value of y, taking x is equals to minus 5 by 3 and y is equals to 7 by 9. Again, we need to verify the result. Let's take left hand side first, LHS, absolute value of x multiplied by y. Put the values of x and y. X is minus 5 by 3, y is 7 by 9. Numerator is multiplied by the numerator and denominator is multiplied by denominator. Minus 35, 9 3s are 27. So absolute value of minus 35 upon 27 is given as 35 upon 27. First result. Second, RHS. Absolute value of x multiplied by absolute value of y. Put the values of x and y, minus 5 by 3 multiplied by 7 by 9. Absolute value of minus 5 by 3, numerical value is 5 by 3 and absolute value of 7 by 9 is 7 by 9 only. On solving, the result is 35 upon 27. Since again the results LHS and RHS results the same, therefore LHS is equals to RHS, therefore absolute value of x multiplied by y is equals to absolute value of x multiplied by absolute value of y, hence verified. Next topic is to compare the rational numbers. Comparison of rational numbers, to compare the rational number, that is to know, to find out which rational number is greater or which rational number is smaller. Comparison of rational numbers. If there are two given rational numbers and we need to find which rational number is greater or which rational number is smaller. We need to compare them. So how to compare? For example, two rational numbers are given. First number is 2 by 3 and second number is minus 1 by 3. We need to identify which number is greater, which rational number is greater. Since 2 by 3 is a positive rational number and minus 1 by 3 is a negative rational number, and we all know that the negative value, negative number is always less than the positive number. Simply, here we can say that minus 1 by 3 is less than 2 by 3. 2 by 3 is greater than minus 1 by 3 because one rational number was positive and other was negative. Here the comparison can be done easily. Minus वाला number छोटा होगा और plus वाला number बड़ा होगा. But if it is given to compare 2 by 3 and 1 by 4, you need to compare these two rational numbers, 2 by 3 and 1 by 4. You need to find which one of them is greater or smaller. Both the numbers are positive. Now, if in this case, we need to convert their denominators in the same numbers so that we can compare by their numerators. Step number 1. How to do that? Step number 1. Step number 1 is find the LCM of both the denominator. Calculate the LCM of both the denominator. LCM of 3 and 4. Since 3 and 4 are co-prime numbers, therefore their LCM is their multiplication. 3 4s are 12. Now, step number 2. Convert the denominators in LCM. 2 by 3. We need to convert 2 by 3 as a rational number with denominator 12. So we need to multiply the numerator and denominator by 4. 4 2s are 8 and 4 3s are 12. Final result is 8 by 12. The same procedure is applied with 1 by 4. 1 by 4. We need to convert 1 by 4 as the denominator 12. 1 by 4. To convert 4 into 12, we need to multiply the rational number in numerator and denominator by 3. In numerator, 3 ones are 3, 4 3s are 12. Now, here the rational number is 8 by 12, here 3 by 12. Since the denominators are same, therefore, the rational numbers whose numerator is greater will be the greater rational number. 8 upon 12 is greater than 3 upon 12. Since the denominators are same, 8 is greater than 3, therefore 8 upon 12 is greater than 3 by 12. Or we can say that 2 by 3 is greater than 1 by 4. Next question. Which of the two rational numbers which of the two rational numbers 5 by 7 and 3 by 5 is greater? Two rational numbers are given. We need to find out which one of them is greater. Given numbers are 5 by 7 and 3 by 5. Step number 1. Find the LCM of the denominator, both the denominators. Since the denominators are 7 and 5, their LCM is LCM of 7 and 5 is 35. Convert the rational number with the denominator as rational number as LCM. So 5 by 7 is multiplied by 5 upon 5. So that number is 25 upon 35. Similarly, 3 by 5 is multiplied by 7 by 7, 21 upon 35. Since the denominator is same, so the rational number with greater numerator will be greater. 25 upon 35, 21 upon 35. 25 is greater than 21, therefore 25 upon 35 is greater than 21 upon 35, or 5 by 7 is greater than 3 by 5. Next question. Next question is to arrange the given rational numbers into ascending or descending order. If we want to arrange any numbers in ascending or descending order, first we need to compare them, which one is greater, which one is smaller. So you need to apply the same procedure on the given numbers. First you will find which numbers are greater, which numbers are smaller, then we will arrange in the order which is asked. Question number 1. Write the following rational numbers. Write the following rational numbers in descending order. Numbers given are 2 by 9, 5 by 12, 7 by 15, and 10 by 40. 4 rational numbers are given: 2 by 9, 5 by 12, 7 upon 15, 10 upon 14. You need to arrange the rational numbers in descending order. So first we need to calculate the LCM of the given denominators. LCM of 9, 12, 15 and 14. LCM will calculate with the method prime factorization. 9, 12, 15, 2, 6 times and 7 times. Again there is one even number divided by 2, 15, 7. Since no even number left, so 9 and 3 will be divided by 3. Again 3. Next prime number is 5. And last prime is 7. Therefore, the LCM of 9, 12, 15 and 14 is given by 2 multiplied by 2 multiplied by 3 multiplied by 3, 5 multiplied by 7. That is 1260, 1260. The LCM is 1260. Now, convert each of the rational number, the denominator of each of the given rational number into 1260. Two by 9, 5 by 12, 7 by 15, 10 by 40. Now, 2 by 9. We need to convert 9 as a denominator with 1260, 1260. So, this rational number should be multiplied by 140. 140 upon 140. 140 multiplied by 2 is 280 and denominator is 1260. Again 5 upon 12. To convert 12 as the rational number of denominator 1260, we need to multiply this rational number as by 105. You can divide this LCM by 12. So result is 105. So multiply since the denominator is 1260, numerator is 525. Next, To convert 15 into denominator 1260, we need to multiply the whole rational number by 84 upon 84. So the result is, denominator is 1260 and the numerator is 588. And to convert 14 as the denominator 1260, we need to multiply it by 90 upon 90. So the numerator is 900 and the denominator is 1260. Now we have got all the rational numbers, converted rational numbers. Now we need to compare them and to arrange them in descending order. In descending order, first we need to write the greater value, the greatest value, and then all of them, the greatest value is 900 upon 1260. 900 upon 1260. Next, the value less than 900 upon 1260 is 588 upon 1260. Next lesser number is 525 upon 1260, and the last is 280 upon 1260. Therefore, the descending order of the given rational numbers are 10 upon 14, which is greater than 7 upon 15, which is greater than 5 upon 12, and 5 upon 12 is greater than 2 by 9. Hence, 10 by 14 is the greatest number and 2 by 9 is the smallest number. Let's take one more example for negative rational numbers. Next question is, write the following rational numbers in ascending order, and given rational numbers are minus 7 by 10, second, minus 5 by 8, minus 2 by 3. Given rational numbers are minus 7 by 10, minus 5 by 8, minus 2 by 3. All these numbers are negative rational numbers. So again, apply the procedure. Calculate the LCM of all the denominators given. So LCM of 10, 8, 3 by applying prime factorization. 10, 8, 3. Since 10 and 8 are two even numbers, divide it by 2, 5 times, 4 times, 3 times, again 2, 3, again it is divided by 2. Next prime number is 3 and next prime number is 5. So LCM of 10, 8 and 3 is given by 2 multiply by 2 multiply by 2 multiply by 3 multiply by 5, which is 2 2s are 4, 8, 8 3s are 24, 24 multiply by 5 is 120. So finally we have got the LCM of the denominators. Next, convert the given rational numbers into the denominator as 120. First rational number given is minus 7 by 10. To convert with the numerator 120, we need to multiply it by 12 upon 12. Numerator is minus 84 and denominator is 120. Next is minus 5 by 8. To convert it into 120, we need to multiply it by 15 upon 15. Therefore, numerator is minus 75 and denominator is 120. Last number is 2 by 3. To convert this rational number as the denominator as 120, we need to multiply it by 40 upon 40. Therefore, the numerator is minus 80 and denominator is 120. Now, Since the denominators are same, therefore rational numbers are compared with their numerators. Minus 75 is the greatest number here, minus 80 is less than minus 75, and minus 84 will be the smallest number. Therefore, minus 84 upon 120, next minus 80 upon 120, and the greatest number is minus 75 upon 120. Minus 84 upon 120 is minus 7 by 10. Minus 80 by 120 is minus 2 by 3. And minus 75 upon 120 is minus 5 by 8. So hence this is the answer, and the rational numbers are arranged in ascending order. Thank you.